Hello, Sushma. Hello. Hello, Sushma.
Yes, sir.
See, link is visible or not? You joined through campus
It's not
Canvas.
visible.
It's not visible.
No, sir. I joined through link.
Link, not the campus connect or
Sir.
campus. Oh.
No, sir.
Actually, enroll the students. The file. Okay, that means.
Yes, sir. Every day I'm joining to the link only, sir. It's
You
not
were-
visible, sir.
It's not visible. Oh,
No,
it
sir.
should. It should be no. So
Yes,
why?
sir. Even
Because
for Nishchita also.
Nishita also. Okay.
Sir.
So actually yesterday I uploaded your register numbers, names, and all those things. Enrollment file I uploaded. So maybe because of that it's not visible. Before and all it is visible, no?
No, sir.
No. Hello.
For me,
The link is
for
visible.
me and Nishchita.
Nishita.
Sir. Both we are logging
As a through Zoom link. Isn't it?
sir.
Oh.
Yes, sir.
Oh, that means
Zoom
maybe the enrollment thing is making problem like this. Anyway, so maybe you since it is already scheduled and it is on, so maybe you can tell to your friends to join through link itself today. We'll see the next. Okay. Okay.
Okay, sir.
Right. Okay, then I will start now. I think we discuss more particularly the azepine. Azepine is uh, a seven-membered nitrogen-containing one. It's a synthesis and chemical reactions we discussed, and today we will discuss about oxepines. So oxepines means a seven-membered ring with oxygen as the heteroatom. And if we are looking into the synthetic methods, so starting with the benzene. So benzene, as per the Dewar scientist or Dewar benzene, we can write like this. It is nothing but a combination of two fused.
Sir, you are breaking.
Hello, yes, yes. Okay, right. So the Dewar, as per the Dewar, benzene can be written like this. That means this is the one of the canonical form of benzene. So this benzene, when it is treated with oxidizing agent, more particularly perhacet, what it will do, this particular double bond is converted into epoxide. Once there is a conversion of epoxide, what will happen? This bond pair is coming over here, and this bond pair will go over here. So that means a what is called as ring expansion to the seven-membered ring. Okay, so that is how oxepine is obtained. Okay, so with this, I will go to the next slide. Okay, I will go to the next slide. Right. So this is about the preparation or synthesis of oxepine, starting with 1,4 dihydrobenzene. 1, this is 1, and this is 4. 1,4 dihydrobenzene. How you can get this? So it is possible to get 1,4 dihydrobenzene starting with benzene itself by the Birch reduction. Okay, and then this 1,4 dihydrobenzene, when it is 1,4 dihydrobenzene, when it is treated with perhacet, it leads to the epoxide. So the obtained epoxide undergoes addition reaction. Addition reaction means addition of bromine to the double bond. Br minus will add to one carbon, Br plus will add to another carbon. So that is how dibromo compound is obtained. So this obtained compound, when it is treated with base, so undergoes a dehydrohalogenation. So that means this bond pair can come over here. This bond pair along with this proton, which will go out as a HBr. Similarly, what will happen here? This bond pair can come over here, and this bond pair along with this proton will go out as a HBr, so forming oxepine. So one more method of preparation of is from the valence bond isomerization. I think you know that. So I think what will happen here, you know that this is a vinyl group, this is also a vinyl group, and this part is called ethylene. So that means divinyl ethylene, and this part is called carbonate. Okay, carbonate. So divinyl ethylene carbonate, okay, in presence of lithium chloride, divinyl uh, okay. So 1 minute. So divinyl ethylene carbonate, divinyl ethylene carbonate, when it is treated with lithium chloride, what will happen? So no, you know that this particular bond will form a bond with this carbon, and this oxygen takes up this a bonded pair. That means, so this part CO2, CO2 carbon dioxide is going out. There will be a new bond formation between this oxygen and this carbon. So that is how a carbonate is converted into epoxide. So from here, it's a 6 electron involvement, and it's a ring closure reaction. So this bond pair, that means here there will be a new bond formation, and here there will be a new double bond formation, and here there will be a new double bond formation. I think these reactions may be something like, I think you are familiar in the pericyclic reaction, cope rearrangement, oxy cope rearrangement. Since there is a oxygen, this should be a oxy cope rearrangement forming a 4 comma 5 dihydro. That means this is 4 and this is 5 dihydro oxepine. Okay. So this is a pericyclic reaction. Okay. So with this, I will go to the next slide. Okay. I will go to the next slide. Oh, now it will come. Okay, and here I am talking about the chemical properties. That means a oxypine, when it is treated with H plus, so a ring contraction. So that means it is possible to get benzo derivatives, or benzene derivative or benzo derivative. So this is the reaction. So that means this oxygen is converted as a OH. Of course, this methyl has it is. So overall, a 7-membered to 6-membered contraction, ring contraction. So what will, if we are looking at the mechanism, it's a 6-electron system. So this bond pair can come over here, and this bond pair will come over here, and there will be a new bond formation between these two carbon atom. So that is how the compound, a 6-membered one, is obtained. So you know that the lone pair present on the oxygen can obstruct a proton and a forming oxonium ion. Once there is a oxonium ion is obtained, so there will be a cleavage, the bond between the oxygen and carbon. So there will be a formation of carbonium, arenium ion. So later on, there will be a loss of proton. This proton will go out, forming a product. Okay, the product is hydroxytoluene, para hydroxytoluene. Yeah, otherwise 4-methyl phenol. Okay, para hydroxytoluene or 4-methyl toluene is obtained when 4-methyl oxypine is treated with H plus. H plus may be from HCl or H2SO4 or any acid source. So with this, I will go to the next slide. Next slide is about the Diels order reaction. So you know that this is a oxypine. It will be in equilibrium with benzoxyrane derivative. So this benzoxyrane derivative is undergoes 4+2 cyclo addition with malic anhydride. So that means this bond pair can come over here, and this bond pair will form a bond with this carbon, and this bond pair will form a bond with this carbon. So this is the obtained one is 4+2 cyclo adduct. Okay. So later what will happen? Photochemical reaction. This is of course this is a thermally hollowed one, and this one is photochemically hollowed one. 2+2 is normally photochemically hollowed one. So 4+2 is in thermally hollowed one. So what will happen here? So there will be a new bond formation between this carbon and this carbon. Similarly, there will be a new bond formation between, no, as I think this is not the correct one, no? So the haro marks is not the correct one. So what will happen here? Not this, okay, I will take. So this particular bond, okay, it will be a forming bond like this. Okay, not this. Okay, not this. That means a 4-member 2+2 addition, but between, okay, I will take a pointer. A 2+2 addition between these two pi bonds, not this. So that means this bond pair is coming over. There will be a new bond formation between this carbon and this carbon. That is how a 4-membered and 5-membered bicyclic compound is obtained. So with this, I will go to the next slide. So next slide is about thiopines. Thiopines means, thia means a sulfur containing one. Epine means a 7-membered ring, thiopines. So if you are looking into the synthesis part, okay, more particularly, you know that this part is called thiophene. This is a thiophene, and 4 substituted, okay, tetramethyl thiophene. So tetramethyl thiophene, when it is treated with dicyanoacetylene, okay, dicyanoacetylene. So here what will happen? There will be a 2+2 addition. So 2+2 addition means it will be, and this reaction is catalyzed by aluminum chloride. Okay. So what will happen here? So there will be a new bond formation between this carbon and this carbon and this carbon and this carbon. So the obtained one is a bicyclic compound. So later stage, this bicyclic compound is converted into a ring expansion and forming a what you call cycloheptane, more particularly thiophene containing heterocycle is obtained. So how it is obtained? This bond pair is coming over here, and this bond pair will go over there. So the obtained one is this. So this is about one method of preparation of thiophene. So with this, I will go to the next slide. So here what will happen? A cis, so this one, okay, cis hexatriene. Cis means more particularly with respect to this double bond, and these double bonds are not, does not exhibit geometrical isomer. So this is the only double bond exhibits geometrical isomer, and this is a cis form one. So what will happen? This also a pericyclic reaction. So you know that maybe dipolar addition reactions. So what will happen? This one react with SO2. So SO2, you know that sulfur is electron deficient one. So what will happen here? This bond pair can attack sulfur. Okay. So when this bond pair is involved in bond formation with sulfur, then this bond pair will move over here, and this bond pair will move over here. And the lone pair present on the sulfur, it will react with this carbon. So that is how a cyclic sulfoxide, okay, is obtained. Okay, right. And later, this one, when it is treated with bromination, okay, more particularly, this double bond is converted into dibromo. Okay, bromo here, bromo here. So later stage, when it is treated with base, dehydrohalogenation. Dehydrohalogenation means this bond pair is coming over here, this bond pair will come over here, and this Br will go out. When Br is going out, it will also take this proton. Similarly, this bond pair is coming over, and this Br minus will go out. When it is going, it will also take this proton. So this process is called dehydrohalogenation. So the obtained compound is what you call thiopene 1,1 dioxide. Okay. So with this, I will go to the next slide. Next slide. Next slide. Okay, I think now it will come. Okay, chemical reactions. So a substituted thiopene when it is heated to 150 degrees centigrade. So what will happen? There will be a ring, what you call 2 plus 2 addition, thermally 1, and what will happen here? There will be a bond formation between this carbon and this carbon. So, and there will be a movement of this double bond to here. That is how a bicyclic compound is obtained. So, it is also possible at higher temperature, okay? And at a higher temperature reactions are called pyrolysis. So what will happen here? A 6-electron system is involved. So that means there will be a new bond formation between this carbon and this carbon. So what will happen here? So when there is a new bond formation between this carbon and this carbon, there will be a migration of this bond pair here and this bond pair here. So that's what the product, a benzotyrene compound is obtained, and this is not stable. So how it will rearranges? Otherwise, there will be a elimination of sulfur. How sulfur is eliminated? So this bond pair is going over here, and along with this bond pair, sulfur is going out. Sulfur. So when sulfur is going, the obtained one is called tetramethylene dicyanobenzene is the product obtained at 400 degrees centigrade when substituted. More particularly, tetramethyl dicyanothiophene is heated at 400 degree centigrade. So with this, I will go to the next slide. So next slide is I'm talking about the so that means up to this we discussed about the a 7-membered ring with nitrogen. 7-membered ring with nitrogen is called uh, azepine. 7-membered ring with oxygen is called oxepine. 7-membered ring with sulfur is called thiopene. So oxepine, azepine, thiopene synthesis and their reactions we discussed. So now we will discuss about the what is called as a 7-membered ring. If a 7-membered ring contains 2 nitrogens at 1 and 2 position, and these compounds are called 1, 2 diazepines. So diaza means 2 nitrogen. Epine means a 7-membered ring. So maybe here we are using the alpha, okay? Alpha, beta, gamma, delta, okay? Unsaturated, unsaturated. Unsaturated means double bond. So diazo ketones, this yeah, okay, N is called diazo. Of course, what will happen? Yes, that's only diazo. Diazo means 2 nitrogen containing one. Undergo electrocyclization. So undergo electrocycle. I think you know that electrocyclization in pericyclic reactions. So what will happen here? here there will be a involvement of 8 electron system, 8 electron or 10 electron system. So you can account that these 2 electron forming a bond with this carbon. So later this bond pair is coming over here, this bond pair is coming over here, and this bond pair will sit on nitrogen as a lone pair. So how many electrons are involved? 2 plus 2 plus 2 plus 2, 8 electron system. Okay, then what will happen? The obtained one is a cyclic compound, and it's a example of electrocyclic reaction. So what will happen here? The obtained electrocyclic product undergoes 1,5 hydrogen shift. This also called as sigmatropic shift or sigmatropic rearrangement. More particularly, 1,5 hydrogen sigmatropic shift. So what will happen here? The bond pair is coming over here. This will come over here, and this picks up this hydro proton. So forming a movement of hydrogen from the one position to fifth position. So that's what the product is obtained. So what is obtained? The obtained product is 1, 2, 3. Okay, 3H diazepine. Okay, of course, in generally what we can say that since the two nitrogens are contained in a 5-membered ring, we can say that 1,2 diazepine. Okay, this is about what is called as 1,2 diazepines, how one can synthesize starting with the alpha, beta, gamma, delta unsaturated diazo compounds. It involves electrocyclization followed by sigmatropic rearrange, sigmatropic hydrogen shift. Okay, so with this I will go to the next slide. So next slide is about the reaction of diketones, more particularly 1,5 diketone. This is 1, 2, 3, 4, 5. 1,5 diketones. 1,5 diketones, when it is treated with hydrogen, undergoes condensation reaction, undergoes condensation reaction, giving rise to a diazy diazepine. Okay, diazepine, right? So this is one more method, and one more method also is possible, that is with alpha bromoazides. So this position, this is the functional group, and this position is called alpha. Okay, this also a alpha, and this is the functional group. So what will happen here when it is treated with this is called ethyl malonate. Okay, of course, general name for this moiety is malonic ester. So when alpha bromohazines treated with malonic ester, so you in presence of base, what base it will do? It will capture a proton, form an anion. So that anion attacks this carbon, and this will go out. HBr will go out. Otherwise, what we can say that sodium bromide will go out. And similarly, one more equivalent of base can capture a proton, forms an anion. That anion form a bond with this carbon, and this will go out. That is how diazepine. Okay, diazepine is obtained starting with this on reaction with malonic ester. So these are the three methods of preparation of diazepine. So let's look into the reactions. So here the reactions are very most characteristic features of more particularly the 1,2 diazepines, their facility for the ring transformations. Okay, more particularly under the thermal and photochemical reactions. So here I am discussing about the what happens when diazepines, okay, subjected to photochemical reactions. So here the common factor you can observe that 2 plus 2 addition. Light means photochemical reaction. Heat means thermal reactions. So what will happen here? 1H. Okay, suppose R is equal to H, then we can say that 1H diazepine. So what will happen here? There will be a 2 plus 2 addition. How? There will be a new bond formation between this carbon and this carbon, and this bond pair is moves over here. That is how a bicyclic compound is obtained. Suppose if these two pi electrons are involved in a 2 plus 2 cycloaddition, that means movement of this bond pair here, and there will be a new bond formation between this carbon and this nitrogen. So this is how the you know that this nitrogen is called bridge ring junction, okay, otherwise bridged nitrogen, okay, ring junction nitrogen containing one, okay. That is the difference between the here. This nitrogen is of course tertiary nitrogen, this is a secondary nitrogen, and this is the of course this also a tertiary nitrogen, but it is present at the ring junction, okay. Of course this is also a ring junction one, and this is a tertiary one. So and it suppose these two, okay, these two pi electrons so involved in a 2 plus 2 cycloaddition in presence of light or photochemical, so there will be a formation of new bond between this carbon and this nitrogen, and there will be a double bond formation here. This is how the product is obtained. And if you want to name this 1 2 3 3H diazepine, and if you want to name this 1 2 3 4 4H. 4H is the partially saturated one. 4H diazepine. Of course, you know that suppose R is equal to H, it's a 1H diazepine. So this is about the photochemical reactions of diazepines. Okay, with this, I will go to the next slide. So next slide, we are talking about the thermal reactions. Otherwise, what we can say is thermal induced reactions. So what is the name of this compound? Maybe, of course, this position is called nitrogen 1 position, and here there is a acyl group, 1 acyl, and 1 comma 2 uh, diazepines. Okay, this you can correct it. Uh, what I will do. So this is a diazepines. Okay, a diazepine. What will happen here? Right. So 1 acyl 1 comma 2 diazepine, when it is heated, so it will be a 6 electron system. How this bond pair come over here, this bond pair come over here, there will be a new bond formation between this nitrogen and this carbon. So that is how intermediate is obtained. And then so there will be a migration. How the migration? There will be how for example, when this bond pair is coming over here and this bond pair is coming over here, there will be a new bond formation between this nitrogen and this carbon, okay. So then the obtained compound is like this. So later on what will happen? Ring expansion. Ring expansion means this bond pair can come over here, this will go over here, this will come over here. So what is the you can observe that of course this is a azarine, and this one is pyridine, okay. Pyridoazarine compound undergoes ring expansion and giving rise to 1,3-diazepine, okay. 1,3-diazepine, okay. Epine, okay. Here also the spelling mistake is there. uh, Diazepine, okay. D-I AZEPINE. This should be E. Okay, diazepine. So what you can say that 1,2 diazepine is gets converted into 1,3 diazepine. Okay, that is the uh, important you need to remember. So under thermal condition, it is possible to convert 1,2 diazepine to the 1,3 diazepine. Of course, this is one unstable species is formed. How this one it is possible? It is possible to form instead of breaking this bond. If this bond breaks, If this bond breaks, then there is a formation of compound like this. Okay. So this is about the thermal conditions of 1,2-diazepine reaction. So with this, I will go to the next slide. So next slide is about 1,3-diazepine. Okay, right, correct. So 1,3-diazepine. This is 1,3-diazepine. So it is also possible to synthesize 1,3-diazepine starting with 1,2-diazepine, more particularly 1-acyl 1,2-diazepine. How? Maybe by thermal condition. That means this on heating. So we discussed just now the reactions of 1,2-diazepine. So that itself is the one method of preparation of 1,3-diazepine. So what will happen? 1-acyl 1,2-diazepine, when it is heated, so it will form an intermediate like this. So later stage there will be a migration. Okay, more particularly what you can say that 1, 2, 3 means 3-position migration. So there how it will migrate? When this bond pair is coming over, when this bond pair is coming over here, there will be a new bond formation between this nitrogen and this carbon. Okay, so forming a pyridohazarine derivative. So later on this will be ring expansion. So that means this bond pair coming over here, this will come over here, this bond pair is coming over here. So that is how 1,3-diazepine is obtained. So with this, I will go to the next method of preparation of 1,3-diazepine. So this is one more method of preparation of diazepine. What you can observe here, uh, more you can say that halo. Okay, this is halo, and this carbon is called carbene. Halo carbene adduct. Okay, halo carbene adduct, and more particularly, 1 position and 3 position is disubstituted. 1 position and 3 position is disubstituted. Okay, and a 6-membered ring with 2 nitrogen and